Okay, let's continue our discussion. Previously, we have seen examples on discrete time convolution and the discrete time properties. So let's continue our discussion on discrete time systems. So we'll see today discrete time system examples using difference equation. So we'll see examples on difference equation. As you know, difference equation equation which relates the input output of a discrete time system. So any discrete time system has its own equation. We call this difference equation of that particular system. So generally we have seen for any discrete time system, discrete time systems take inputs. After processing, they give us new signal output of response y of n, right? So generally we can write the output side, the summation of k from 0 up to n. N is the order of the difference equation. On the output side, n minus k. So you see here, n can be 0, so y of n. When n is 1, y of n minus 1 up to what? Up to n. The summation of outputs, present output and all the last outputs equal to, on this side, inputs. Again, inputs can be present input up to m values of the past input. So n minus k. So k can be 0 up to m. So this is the general form of difference equation we have discussed last time. So any discrete time system represented by the equation called difference equation. So today we'll see some examples to give you idea about this difference equation. Okay, so let's start from our first system, which is called 6-point averaging, or it's called also moving average filter. So this is a system. Let's put the system in block form here. Okay, so this system is 6-point. I will explain why we call it 6-point average. This system is 6-point averaging. Okay, so as we know, it's a system which takes input signal x of n. Let's say this is our input discrete time signal. It's processed here, and we have output sequence y of n. Okay, so as you know, as you understand from the name, this system, it takes the present input x of n. This is our present input, right? The input applied at currently x of n, So x of n, from the input side, we have x of n, okay? Then plus the last value of the input, x of n minus 1. This is delayed by 1, okay? The input, x of n is the present input, present at this time, the input at this time. X of n minus 1 means the inputs, the sample before one sampling time, x of n minus 1. So how to get it? We need a memory element or unit delay element. One of the basic components for realizing a discrete time system is memory element. The symbol z the power of minus 1. So if you apply this input for this memory element, it will give us output. What is the output? The delayed one. Input delayed by 1. Delay means past value of inputs. Okay. Now they have to what? They have to add this together. So we need another circuit element called adder. In analog system, as you know, we use capacitor, resistor, and so on. Here, our basic components are so this signal, which is a previous input, it comes here and added with the x of n. Again, we need to add in our equation not only the input before one time unit, input before two time units, x of n minus 2. So this xn minus 1, again delayed by 1 unit, delayed by 1 time unit. For that, we need this delay element, okay? So when you delay it, what do you get? Xn minus 1, again delayed by 1, it will be xn minus 2, okay? x minus 2. This is input before two time units. It is a past inputs. This also must be what? Must be added together. Look here in the equation. What is output? Output is x of n plus xn minus 1 plus xn minus 2, then plus xn minus 3. Okay, so how do you get xn minus 3? We need another delay element here, unit delay element in our circuit. So again, xn minus 2 delayed by 1, it will be what? xn minus 3. What's xn minus 3? Input sample. The last input sample before 3 time units. This also must be added together. So we need adder. This is adder circuit. Okay. Any more? Yes. We need also another input. So give it here. This is a delay element. So what will be the output? The output will be x of n minus 4, right? X n minus 3 delayed by 1, we get it. This also must be added. X n minus 4. One more, right? You see our equation. So one more delay element. So z the power of minus 1. What do you get? This again x minus 4 divided by 1, x n minus 5. Okay, so this, sorry, it's here also. All must be added together. Look here. So what do you get at this circuit output? X of n comes here plus x of n minus 1 added here plus x n minus 2. All the input, the present input x of n, and the 5 most recent inputs up to what? X n minus 5. Okay, 5. So look here. This is the present input, right? All these are x of n minus 1, x of n, their last value of inputs added together and how many samples? 1, 2, 3, 4, 5, 6 samples. So when you divide it by 6, it will be average. That's why this system is called 6-point average. We add the last 6 most recent inputs together. This system is doing what? Look here. Input signal you apply. So how many delay elements we use? 1, 2, 3, 4, 5 delay elements on this side. How many other circuits? 1, 2, 3, 4, 5 other. So this system is constructed using 5 memory units, 5 others. And after adding all, the whole is multiplied by what? 1 over 6, because we need average. When you multiply by 1 over 6, this is a multiplier. Okay. All these are multiplier 1. 1. This is also 1. This is also 1. This is also 1. This is also 1 multiplier. This also 1. Because as you can see here, the coefficients for inputs are 1 added together and finally multiplied by 1 over 6 to take the average. It will give us what? It will give us the output. So look here. Y of n is the average of the 6 most recent inputs. Average means summation divided by number of samples, right? Here, how many samples? 6. X of n, xn minus 1 up to n minus 5. X of n is input, present input. Start from xn minus 1 up to n minus 5. Last inputs, all added together. Average means divided by number of samples. There are 6. We get the average. That's why this system is called 6-point averaging system. This design will come in chapter 4. Here just I want to show you. So this system, it is called non-recursive system. Why we call it non-recursive? Because the output, as you know, as you can see from this equation, this difference equation, the output depends on what? Input, present input, and past. All these are past values of the inputs. The output does not depend on past values of outputs. Say type of system where output does not depend on previous or past outputs. the output at this time, y of n, as you can see here, y of n depends on what? This y of n, our output of the system, depends on x of n, which is input, current input, depends on xn minus 1, last input before 1 sampling time, depends on x minus 2, input before 2 sampling time up to xn minus 5. These last 5 recent inputs plus the current input added together, take average, it will give us the output. So output in this case, in this system, depends on the previous outputs. Previous or past outputs does not affect the present output. Say type of system, systems are called non-recursive systems. So this system is used for smoothing out fluctuations. If there is fluctuation, rapid change in your signal, it will be smoothed out. So it's smoothing out fluctuations by doing what? It will attenuate high frequency components of the signal. Attenuate means decrease, diminish high frequencies, because these high frequencies cause fluctuations, right, in our signal. So these high frequencies in our signal are attenuated. Frequencies, okay, and it amplify low frequency components. Amplify means increase, so positive attenuation. Amplify which components of the signal? Low frequency components of the signal. So low frequencies will be amplified, high frequency will be attenuated. That's why this system is used to smooth if there is fluctuation, high speed, fluctuations in our system, rapid change, it will be smoothed out by this system. As you said, system is used to process a signal, right? So we need, if you need a system which smooths fluctuations or to amplify low frequencies and attenuate high frequencies, we use this 6-point averaging or moving average filters. Therefore, moving. What type of system? Non-recursive. We'll see next what recursive means. So, as you can see here, this is our system with difference equation here. Okay, so what type of system? Summation of these 6 inputs divided by 6, it is averaging, right? Averaging. So